Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome to my channel, Budi Haloman Siregar. Our topic today is about sensitivity analysis. However, it is only the part 2, and the part 1 you can see the link above. In the first part, we have discussed about sensitivity analysis. It is about the what is the optimal table analysis, the changing of the objective function coefficient, and also change of the right hand side value and shadow price. However, in this topic, we are going to discuss about addition of a new variable and the addition of the constraint. Okay, the first topic is addition of a new variable. Addition of a new variable to a linear programming problem means addition of a new product. All right, because actually the variable is referred to a kind of the product. For example, in Panglong Jaya, you can see the original problem. The original problem in the link above. However, for this one, we change this problem. For example, in Panglong Jaya trading business problem, X is refers to the door productions, amount of the door productions, and Y is the number of windows production, right? For example, the trading business wishes to add a cupboard. That means it is a new product that should be produced. To produce 1 unit of cupboard takes 2 hours in manufacturing process and 4 hours in printing process, with a profit 500,000 rupiahs. Okay, it is a new variables or a new product. After construct the models, we find like this: maximization Z 400,000 X plus 200,000 Y and 500,000 W. That means W is amount of cupboard should be produced. And the second and the first constraint we convert like this with 2W. However, in the original problem only X and Y, right? So we add the first constraint with 2W, less than or equals to what? 100. And that's in second constraint. In original constraints only 3X and a plus Y. However, in this problem we add by 4W, less than or equals to 180. It is the constraint of printing. It is in hour per weeks, and it is the non-negative constraint. X, Y, and W greater than or equals to 0. Of course. All right, attention please. Station made me 15 minutes to go to discuss about this one. To find out whether the cupboard production with profit 500,000 rupiahs per unit can increase Panglong Jaya trading business profit, then it needs to be analyzed as follows. To determine the new column factor value and interval value by using the following formula like this. It is the formula: column factor values NB equal B inverse times CI. Interval value equals CB NB. What the meaning this variables? The symbol NB is equal column factor value, B inverse equal pivot metric X metric contained under the initial basic variables. CIZ is the new variable coefficient. CB is objective coefficient of basic variable based on the optimum value. So you can find this one in the optimum value. Okay. So for the Panglong Jaya problem, for the first we have to find the column W value. Is the so it is we have two. It is the what do you say? It is the initial metric. Actually, it is initial metric. However, uh, the another name is key metric. It is the key metric. Okay, you can find this metric in the optimum table solution in the last table. After that, you have to multiply it by ci. What is the ci? CIZ or CIZ, the new variable coefficient. It is the new variable coefficient. You can see to the original problem, 2 and 4. It is 2 and 4 coefficient of the first constraint of W, and it is the 4. Okay, so we find 2 and 4 from the coefficient of W. Is the coefficient of W, and then we multiply this matrix, and the result is 1 1 like this. It's the column W value 1 1, and then after that we have to determine the interval value. The interval value is the coefficient of objective function CB. CB coefficient function of basic variable. It is basic variable. Why it is 200 and it is 400? It is actually because the optimum solution is in the basic variable is y. The first is y, and the second one is x. So you have to put the y for the first year. It is 200, and then x 400, and multiplied by the column W value like this. It is 1 1 and minus C3 and C like this, and multiply this one, so you will find this one. Okay, any questions so far? If you have a question, you can comment in my channel YouTube. Okay, to determine the feasibility of carbon production activities, it must require 600 minus C 3 cap like this, less than or equals to 0. Therefore, the 10 interval value is C3 greater than or equals to 600. Thus, the production of cardboard will be economic if the profit is at least 600,000 rupiahs. Instead, if the profit is less than 600,000 rupiahs, it is better not to produce the new product of the cardboard. Okay, it is the second topic. It's the second problem. How if we add a new constraint under any kind of a problem? For example, in this Panglong Jaya problem, we add a new constraint. How to solve this one? Do you want to solve this one by a simplex method you from the start step? Of course, it is not effective. Okay, adding a new constraint is required because the company needs a new resources with the aim of increasing profit. Okay. Sometimes the company need to add any kind of new constraint. However, the addition of the new constraint may not necessarily increase profit or reduce production costs. Thus, before deciding to add a new constraint, it is not boundaries, it is constraint. It is necessary to analyze the change. Okay, before the company decide to add a new kind of the new constraint, of course we have to analyze if it is give a good effect or negative effect to the profit of the company. Okay, now because why? The addition of a new constraint will lead to the two possibilities. The first is if the new constraint is passive, it will not change the optimum solution, because if the constraint is passive, that means it will not give any kind of effect to the profit. However, if new constraints are active, they can have an impact of increasing profit or decreasing production costs. This limited call to be active if does not violate to the rules of the optimum solution. Okay. Okay. For example, Ude Panglong Jaya need new resources by adding three third constraint like the following. It is the first constraint. This is the originally constraint. However, it is if you see to the Ude Panglong Jaya, you can open the original problem here. Okay, it is the link. I mean, and then it is the second constraint. It is the original constraint. However, if we add a new constraint like this, x plus 3y less than or equals to 230. For example, it is the time limit or hour in hours engraving over week. It is the first is manufacturing, and the second is the time of painting, and the third is engraving time, right? It is in hour per week. It is the non-negative. Okay. It is the optimal solution in original problem Ude Panglong Jaya. The Z is 28,000 rupiahs. It is in 1,000s. That means 28 million, and it is 60. In it, the X is 40. Okay. After determine the new constraint, then it needs to be tested by substituting the optimal table-based variable value on the new constraint. After you determine this constraint, you have to test this constraint. It is give effect or not any, not at all. For example, we have find x is 40, y is 60. We substitute this one to the new constraint like this. So 40 plus 3 times 60, right? Less than or equals to. It is 220. Since 220 less than or equals to 230, is it true? It can be concluded that the addition of the new constraint is passive and will not affect the optimum solution. So if the constraint like this, it is will not give effect to the profit. Okay. That means if the company wants to add a new constraint, should be changed, not like this, because it is no effect at all. Okay, what Sparse the value to the right hand side of the new constraint is changed like this: x plus 3y less than or equals to 200. So we change this one. The first is 230, and the second one we change to be 200. Then 220 is less than or equals to 200. Is it right? It's wrong, right? Uh, that means this constraint is active and will have an effect on the optimum value. Furthermore, it needs to be investigated whether the effect is increasing or reducing the profit. Sometimes the new constraint can increase the profit. However, on the other hand, maybe there is a probability that the new constraint can affect to the reduce of the profit. Okay, to determine the optimum value after adding the constraint is changing the model into a standard form like this. It is the standard form for the Pangjaya. It is the second constraint, is the new constraint like this. Up to that, we put this one to table simplex like this. This x, y, and it's 3, right? We put this one like this. 1, 3, 1, 3, and it is 1. 1, 3, S3, right? 1 like this. Okay. Based on the optimum table, the basic value are x and y. So the element in x and y column contained in S3 row must be 0. Must be 0, right? It is because it is the optimum table, and we put in S3 here. All right. This thing is executed by subtracting or adding with x or y row element like this. Step 1. Determine the S3 row element in X column becomes 0 like this. S3 row it is 1, 3, 0 and so on, and it is 200, and times with 1 times element X row. X row is 1, 0, negative 1 over 2 and so on is 40. After calculating this one, you will find this is the S3 row element in X column, right? And then the step 2, select the S3 row element in Y column become. This thing is executed by subtracting or adding with X or Y row element. Step 1, determine the S3 row element in X column becomes 0 like this. It is S row and then 1 times element X row. This one, right? So after calculating this one, you will find like this 0, 3 and so on. However, the step 2 is select the S3 row element in Y column becomes 0 like this. It is the S3, it is from this one. It is, okay. And then 3 times element Y row. It is Y row, right? And then after calculating, we'll find like this. Step 3, put insert or put the new S3 row element into optimum table like this. After you're finding this one, put here. Here, here, right? Okay. After that, is it optimum? Of course it is optimum because there is no negative value in the z row. However, it is not possible because there is a negative value in the right hand side or in the solution column, right? It is negative 20. So how about this one? The table of is still optimum because all the element in 0 is positive, right? However, the right hand side value of S3 is negative. It can be concluded that the table is in optimum condition, but it is not feasible. So it needs to be solved by applying the simplex dual method. Okay. However, uh, we are not going to discuss about simplex dual method in this video. We will in the next video we are going to give you we will give you about the video maybe some days to go. Okay, thank you. If any question you can comment in my channel. Stay tuned with me, Budi Haloman Sregar. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh. Mana tadi ya? Ini